Hi guys, this is Dr. G here, and in this short video we will talk about radical halogenation of alkanes. So as you already know by now, alkanes are also called paraffins. Why? Because they do not react as most chemicals or most organic compounds. Alkanes are very inert or highly stable. So finding reactions for alkanes are difficult. And one of the very common reactions that alkanes will display is actually a radical reaction. Radical reaction. So for this radical reaction, you are going to need a halogen, preferably a chlorine or a bromine. For this radical reaction, you are going to need a halogen, preferably, let's say, a chlorine or a bromine, because fluorine could be too reactive and iodine could be very slow. And then you are going to need a simple alkane, okay, a few carbon alkane. So those are the preferable reactants for this radical halogenation, okay. And as the name implies, this reaction is a radical reaction, okay. This is a radical reaction, and therefore the bond making and breaking is going to be symmetric, okay. The bond making and bond breaking is going to be symmetric, which means we are going to use half-headed arrows. We are going to use half-headed arrows, okay. We are going to use half-headed arrows. Usually electron movement is shown through full-headed arrows, right? But instead we are going to use half-headed arrows. Half-headed arrow means it basically shows you the movement of one electron, okay. It basically shows you the movement of one electron, okay. So we are going to use half-headed arrows in this reaction, not full-headed arrows, okay. All right, so as I mentioned before, this radical reaction, okay, could be very reactive. So therefore most preferably we will use chlorine, okay, or bromine. And this radical reaction happens in 3 steps. Actually most radical organic reactions happen in these 3 steps, okay. The first step is actually called initiation, okay. The first step is called initiation. So during the initiation you are going to form a radical, okay. For this reaction to happen, you are going to need radicals. So during the initiation step, you are going to form radicals from non-radicals. So in this reaction, you are going to form a radical from halogen, okay. So you are going to use your chlorine molecules, and then you are going to make a chlorine radical, okay. So this is the first thing that we are going to do, that is initiation. Why? Because you start with a non-radical, which is chlorine molecule, and then you ended up with a radical molecule, okay. And the next step in radical reactions is called propagation. So basically propagation is where you will transfer one radical from one molecule to another, okay. So you are basically transferring the radical from one molecule to another. So you are planning on transferring this chlorine radical, you are planning on transferring this chlorine radical into an alkane, so that alkane will be very reactive, and then hopefully it will substitute a chlorine, okay. So propagation is basically transferring of radical from one molecule to another. And the last step is actually called termination. So during termination, you are reacting two radicals. And this reaction will basically give you a non-radical, okay. So you are basically killing the radical reaction. But here's the thing, in radical reactions, more than 90% is actually propagation, okay. So once you start or once you initiate a radical reaction, it will remain at the propagation step, okay, for a very long time. And then termination will be very small, okay. Termination will be very small. So therefore once you start a radical reaction, usually it goes to the fullest, okay. I mean, once you start a radical reaction, it will continue until there are no other suitable molecules for the reaction, okay. So radical reactions are highly harmful sometimes. I mean, you guys know that people or environmentalists worry about ozone layer, and ozone depletion is actually a radical reaction. Once the ozone depletion starts, it is very hard to stop it. Why? Because unless there is a termination step, you will always have a radical in the medium, and then it will continue to the other propagation steps, okay. So we will talk about it in more details. But radical reactions could be very aggressive, and it is very hard to stop them. All right, so in this reaction, the initiation step that we have is the formation of chlorine radical, okay. So for the formation of chlorine radical, you're going to use the chlorine molecule, Okay, and then for this radical formation you are going to need sunlight. Okay, chlorine is a stable molecule, it is not going to form chlorine radicals without any reason, so you will use some sunlight. Once sunlight is exposed to chlorine gas, the the bond between chlorine and chlorine, the bond, excuse me, I have a 2 here, so the bond between chlorine and chlorine will break symmetrically, which means you have 2 electrons shared between the 2 chlorine atoms, right? So you have 2 electrons shared between the 2 chlorine atoms, and this symmetric bond cleavage will basically take 1 electron and give it to this chlorine. The other electron will go on to the other chlorine. So this symmetric bond breaking will form 2 chlorine radicals. Okay, it will form 2 chlorine radicals. And once you start a radical, it will easily react with stable molecules such as alkanes. Okay, so once you have a chlorine radical present in, let's say, in the present with methane, which is a very stable gas. Okay, methane, CH4. Okay, it will easily react with chlorine radical. So chlorine will bring 1 electron to the table, and it is planning on reacting with this hydrogen, right? So hydrogen is already bound to this carbon, so it has to break this bond. It has to break this bond. So it will break symmetrically, and 1 electron will go between hydrogen and chlorine, and the other electron will go and sit on carbon. Okay, so the product that you expect is a bond between H, hydrogen, and Cl, and of course you are making a CH3 radical. So as you can see, you started with the chlorine radical and you ended up with the CH3 radical, methyl radical. Okay, so you started with a radical, you ended up with a radical. So whenever you have radicals remaining in the medium, they can react again. So let's react our CH3 radical. It can react with many things, but let's react it with another chlorine molecule. Okay, and when you react it with another chlorine molecule, you have to make a bond between the radical electron and one of the electrons from chlorine. So chlorine will break the single bond between the 2 chlorines, and it will bring 1 electron to the table, and the other electron will go on to the remaining chlorine. So what you have is an alkyl halide, CH3 Cl. Okay, and also you are making a chlorine radical. So we can continue this reaction. So you started with a radical, you ended up with a radical. Okay, you started with a radical, you ended up with a radical. So you can continue. So you will use this radical, you will use the chlorine radical and then continue the reaction. Let's react it with CH3Cl. Okay, so let's react it with CH3Cl. Okay, so chlorine will bring 1 electron, the other electron will be from the carbon hydrogen bond. So hydrogen is taking 1 electron from carbon and give it to chlorine, and the remaining electron will go on to carbon. So what you have here is HCl plus CH2 Cl. You started with a radical, which is chlorine radical, and you ended up with a radical. So you can continue this reaction forward. So you have CH2 Cl radical, and it will, let's react it with chlorine. It could react with many things, but let's react with a chlorine molecule so that you can get another chlorine. Okay, see, when radicals are reacting, it will only bring 1 electron, so the other atom has to bring 1 electron. So this chlorine bond will break, and 1 electron will go and react with the carbon electron, and the remaining electron will go on to chlorine. So you are forming a chlorine radical, of course, and you have a CH2 Cl2. Now carbon has 2 chlorines. Okay, so you started with a radical and you ended up with a radical. So you can do this. Okay, you can continue to do this until you chlorinate the carbon fully. Okay, so you can substitute both the other hydrogens with chlorine. Okay, so I want you to pause the video and see if you could do it by yourself without my help. See if you could continue this mechanism until you get CCl4. Okay, see if you could get CCl4. All right, so pause the video and see if you could do that. Alright guys, so I actually completed this reaction for you. Okay, so as you can see, we started with a chlorine radical, and in the process, in the propagation process, we ended up making CH3Cl, CH2Cl2 or dichloromethane, and then chloroform CHCl3 and CCl4. Okay, so all these products are possible in this reaction. Okay, so you can start with somewhere and you should be able to show how you can get any one of these four products. Okay, it could be CH3Cl, CH2Cl2, chloroform, or CCl4. Okay, so you should be able to write the mechanism and show me how this reaction will occur in order to produce these products. And also the thing to remember is that you will always start with a radical, and you will always regenerate another radical in the propagation step. So now let's talk about termination. Which is the final step, or how to get rid of the radicals. Okay, so last thing that we are going to do is talk about termination. So in termination, as I mentioned earlier, you are reacting two radicals. So the most common radical is chlorine radical. Okay, two chlorine radicals, when they meet, they can react, okay, and form a chlorine molecule. Sometimes you could have a chlorine radical reacting with a methyl radical. If this happens, it will form methyl chloride. Okay, so as you can see, none of these reactions are forming another radical. So this is why they are called termination. If you don't have another radical, these things can't react further. Okay, so that is why it is called termination. I mean, you can write many other. I mean, sometimes you can react two methyl radicals if you want to. I mean, if two methyl radicals meet each other, they will react and form an ethyl. Okay, an ethyl. So many things are possible. Sometimes you can have a CH2Cl radical reacting it with another chlorine radical. Okay, if this happens, what you get is CH2Cl2, dichloromethane. Okay, so you can write many other termination reactions, but only thing that you have to do is make sure to use two different radicals. Okay, you will always use two different radicals. You can use any one of these radicals and then react them together and see what kind of products that you get. But once again guys, these termination reactions are very rare. Okay, why? Because for terminations you are going to need two radicals. Okay, so there are more one radical and molecule as compared to two radicals meeting together. Okay, so therefore propagation step is very vigorous as compared to termination. With that, I'm going to conclude this video. Please let me know if you have any questions. Okay, you guys have a good one. Take care.